Hey everybody, let's take a look at 2-3 reflections today. What I'd like for you to do is do your warm-ups 1 and 2, hit pause, and play when you're ready to check your work. All right, how did you do? So we translated the first one 6 units right, and then the second one 2 units left, or 1 unit left, and 2 units down. Today we're going to take a look at a different transformation. Today we're going to look at a reflection. Now a reflection is really just a flip that is transformed over a figure in a reflected line. Now we call that line, well, line of reflection. Now what this does is it creates a mirror image of the original figure. So if I were to look, this is this distance and this distance apart. Notice each point is the same distance apart. So taking a look at example 1, which one of these tell if the blue figure is a reflection of the red? So we're starting here. Are each one of these points the same distance? And this here is, yes, here to here, here to here, same distance. Here to here, here to here, same distance. Now, this one is not a reflection because this point right here from here to here is not the same distance. It's not a mirror image. So if this were 3 points away, it should be 3 points away. So this is simply a slide. So on your own, 1, 2, and 3, tell us which one of these is a reflection. Hit pause and play when you're ready. All right, so this one was a no. That's a slide. This one also is a slide, as where here, these are a reflection. All right, so how do we make a reflection here? Now, if we want a reflection in the x-axis, we're going to find the opposite of y, because we want our x value to be the same. For the y-axis, we are going to flip the x. So again, we'll want that y-axis to look the same. Well, what does that look like? So we've got a triangle here, A, B, and C. So I want to reflect it along the x-axis. So here is our x. That means if this is one spot above the x, A is now one spot below. If this is 1, 2, 3 above, it's now 1, 2, 3 below. Notice the x value is still the same, but the y value is the opposite. So here I've got 1, 2, 3. So I'm going to go down 1, 2, 3. And here's my C prime. So my A prime, notice I've got -1, but now -1. So the x is the same, but my y value is the opposite. So here my B was at -1, -3, and C prime, same x value, opposite y value. So let's now take a look here at a quadrilateral P, Q, R, and S. Draw a figure and its reflection. So I'm going to go ahead and draw P, which is at -2, 1, 2, 5, 1, 2, 3, 4, 5. So that's point P. Q is at -1, -1. R is at -4, 1, 2, 3, 4, 2, 1, 2. That's R. And then S, whoops, Q was -1, I went +1. And then S is at -4, 1, 2, 3, 4, up 4, 1, 2, 3, 4. So this point is S. Now, I want to flip it or reflect it in the y-axis. So I've got 1 here, 1 here. Up here, I've got over 1, 2, over 2. So label that Q prime. P prime, I've got 1, 2, 3, 4, 1, 2, 3, 4. Notice my Y value is staying the same, but my X value is now the opposite. So I've got the vertices of P, Q, R, and S, -2, 5, -1, -1, R, -4, 2, and S, -4, 4. Now I'm reflecting in the y-axis, which means I want the negative X value and the Y value. Okay, and then that's going to give me the vertices of P prime, Q prime, R prime, and S prime. So opposite of -2 is 2, Y stays the same. Opposite of -1 is 1, Y stays the same. Opposite of -4 is 4, Y stays the same. S prime, -4, opposite of -4 is 4, Y stays the same. As I'm reflecting it along the y-axis, Y stays the same. We find the opposite of X. All right, go ahead, try on your own 4. Do A, B, and C. Hit pause and play when you're ready to continue. All right, how'd you do? So we've got our reflection in the X, reflection in the Y. Are they congruent? Yeah, they're still the same size and shape. Nice job.